The verification tools for Spark basically are analysing a mathematical model, if you like, of the meaning of a Spark program using various forms of analysis and verification technologies. So underpinning Spark, if you like, is a mathematical system. The good news is that mostly you don't have to understand that. Mostly the mathematics is hidden from the user, and the tools do what they do and produce you results in a readable form that you can understand. And the tools will say, hey, look, I found a bug, it's here, and in this case there will be this bug in your program or something like that. Or the tools say yes, and they say, yep, I haven't found any bugs at all, and that's great, and that gets you some sort of assurance that you might want. So to the large extent the mathematics is hidden, and that's a good thing. The history of formal methods research, I suppose, is a story of mathematics going from being explicit in some pen and paper form to being very well disguised and hidden within tools, and that's common in all engineering disciplines. Say the aerospace industry is underpinned by an enormous body of mathematics in computational fluid dynamics and aerodynamics and this kind of stuff. But these days it's incredibly well hidden behind incredibly powerful tools, and people use supercomputers to design aircraft these days, not pen and paper. The same with software engineering. Perhaps we're at an earlier generation of that kind of process. But with Spark, what we're trying to do is take that mathematics and hide it as well as we can behind the user interface offered by a programming language and a development environment, which makes the mathematics almost disappear into the background as much as we can.